Well, hello everyone. Yeah, as I can see we have almost half of the registered attendance already logged in, and I can see that you know how to use the chat. But yeah, so thank you very much to everyone for registering for this webinar, which will be a very quick overview of our free processing seismic processing tool, InSite-Lite. Some initial housekeeping. All you are muted, but you can use the chat, which should be on your screen, to post any questions. We will try to answer them at the end of this quick walkthrough. Questions about what we are covering today, or about our other software packages, or more general questions. Any question is welcome. Here with me today is Nicola Matthews. She will be managing this webinar. She's also the InSite software product manager. My name is Juan Reyes Montes, and I'm a consultant, senior consultant at Applied Seismology Consulting. Let's wait for a minute until make sure that everyone is in. Yeah, I think most of us are in. Yeah, and it will help us just to know how you find about this webinar. If you can just quickly answer the poll that has been posted on the website, on the webinar website, just to know how you heard about us. I know a few, or most of you probably are familiar with InSite, already users of InSite. You won't see much new on this webinar, I'm afraid, but well, you will see what's available as a free tool. Okay, let's move on. I think we are mostly all of us are here now, so let's move on to this presentation. And a quick introduction on InSite seismic processor. So InSite is our software that integrates both the management, the processing, analysis, and interpretation of passive and active seismic data. It's been developed, it's been in the market for the last 20 years. And it's being used by many clients in many different areas, from research institutes down to industrial applications and engineering applications of seismic monitoring. It's used on many scales. The tools in InSite are valid at any scale, from processing acoustic emissions in the lab in rock deformation tests, up to processing local and regional seismicity. The processing is very similar. It's got differences, but all the tools, or we aim to have all the tools integrated within InSite. And well, it's got several releases during the year. The latest release was in this last September. It's 3.16.3, as you see there. There will be a new release in the new year, which will go up to 3.17. Okay, so the aim of InSite is to cover most of the steps in the standard seismic processing workflow for seismic data. Here we're going to show the areas, the steps that are covered by the free version of InSite, InSite-Lite, which start, as with any software tool, with the setup of our project, then go into data harvesting and data import. Have to say, InSite-Lite does not allow you to harvest data, but we'll see ways around it, but definitely allows you to import data that has been previously triggered by any other acquisition system or any other processing tool. Next step is some tidying up of your waveforms. There's some pre-processing in your waveforms that we will see what it's covered there. Very important, classifying what we see, what we have as triggers, and the standard classification is whether our signal is noise, still useful, but not our main object. Shots, very useful for calibration, but probably not the main object of seismic monitoring campaign. And of course, the events. Once we have the events, next step will be the processing of them, which involve basically identifying, identifying phase arrivals and locating our events. And then, of course, analyze, do some analysis on what the patterns that we see in our seismic cloud and our seismic data, and export it either as a event catalog, if our interpretation is complete, or as waveforms to process on third party or on our own algorithms, using our own algorithms for further processing. So saying, the first step with any software tool is setting up a project. In the case of InSite, this first step, a requirement for InSite, is setting up our seismic stations. They can be seismic stations, they can be geophones, downhole geophones, they can be sensors that surround a sample in the lab. But we need to define them in InSite. InSite is ready for all sorts of configuration. We can handle tools that are positioned downhole wells, on the surface, surrounding a sample, or a combination of all of them. And it can take any response, so voltage, which is basically an uncalibrated sensor, or if they're calibrated and we know the response of them, we can set our tools as responding to acceleration, velocity, or displacement. So let's have a look at the software itself, at InSite-Lite, which is here. This is the first screen that you see. For those of you that are familiar with InSite, you will see it's exactly the same interface, only that you will notice some tools as we go through them are not available. Of course, they are only in our other packages of InSite and the full packages of InSite. But the basic navigation and setup is the same for all of them. So this is our first starting window. It is very much a Windows Explorer setup in which we have two columns. We will see these two panes being populated later when we have events. So one pane that will contain the folders containing our events, and another pane that will show all the list of our events that we have processed in InSite. But first step that we need to follow is setting up a default receiver array. And we do it here by clicking here. And there are several ways to do it. The probably simplest way is just add one by one our instruments. And we can see here, by default, it comes as with a voltage response if we don't know what, if our tool is not calibrated. If we know what it's responding to, then we can select what is the response of our instrument. On a single channel, normally, or in many cases, we can work normally do the acquisition with triaxial instruments. In that case, we add more channels onto it and specify here what will be the orientation of our channel and the response of our channel. I have to say, it is not, none of this information is required. It's not essential at this point to set up our project. All we need to have is the correct number of channels, because at the time of importing data, InSite will assign a trace to a channel. So it needs to have a space for it, a channel defined in it. We can, at a later stage, update this information once we know where our sensor is located, or if we recalibrate it for some reason, and update the information. But it is essential that we have the right number of channels set from the beginning, at the start of our project. So this is one way. It's adding our channels one by one. Another way, it's, see here, import them using a pre-prepared file. It's just a text file. Yeah. And it's, yeah, very simple to set up. I can show you an example of it, which will be here. It's yeah, very simple text file. That contains, well, the basic information of our tools, which will be the channel number, the number of channels per instrument, the position of each of these channels. The rest of the information is not required, but yeah, we need to have the space for it. So you can see here, it's the same information that we can input on the interface, on the software interface. Okay. So once we are happy with that, we can close it, and we go to the 3D visualizer just to see if our tools are visible. Yeah, and we can see here, or in this case, our 12 geophones have been imported and are added. I had prepared this before, adding what would be the outline of 2 wells, 1 monitoring well and 1 treatment well. Yeah, you can see that the tools are there, and we are ready to get to the next step. So once we have set up our project, the next step is get data, seismic data into InSite. The standard process would be harvesting this data from the continuous record. This tool is only available in the full version of InSite. So we have to, in this case, we have to import either raw data, as it is, continuous data into InSite, or import pre-triggered events into InSite. I'm going to show you on the software how it works, but this is the basic dialog that we have. You can see there's a big list of formats. It's quite versatile in the format that we can import data into InSite. So you can see some familiar data, some standard types, SegY, Seg2, SISAM, mini-SID, SID will be there as well. And some more obscure data, which is basically client, some proprietary data from clients. So this is something that we can do for you as well, prepare an interface for importing your own data. Yeah. Once this data is imported as SegWire or any other format, InSite converts that into ESF files. It creates 1 file per event, and this is the proprietary data for InSite. And yeah, we're ready to work with it. So let's go to the software and work with our data. So we simply, I'm right-clicking here and yeah, select import data. In this case, I've pre-selected SegY, and I'm going to work in this case with raw data just to show something that we can do if we don't have or working with trigger data. So yeah, if we're happy, we can select how many of these we want to import, and only can import 3 of them in this case, just to show Yeah. Okay. This is basically works like a Windows Explorer, so I can here create folders which are called components. I can rename them, and we'll call this extracted data. Yeah, that name. And let's have a look at the traces that we have imported. So saying this is a continuous trace, has been automatically processed. Yeah, and we can visually detect some arrivals here that might be events. There's a clear one here that could be probably our S-wave arrival, or probably what we have at the front might be our P-wave. So we don't have the tools for extracting this data in the free version of InSite. In the full version, we will use the Streamer-Lich, which will have some logics and different algorithms and logic to extract events and detect events. But in this case, with our free tool, close this, we have to do this visually. And I'll basically select the section of my trace that I think corresponds to my arrival. Probably this is too much. I'm just gonna zoom in a bit more. And I would think, yeah, this is my arrival. So if I'm happy with this, once I have that, I can select my, use this tool, which is the time cropped event. What it's done is take almost like a snapshot of what I'm seeing at this point, and I will send it to my extracted data folder. Okay. And if I move this, I can go to the next. Yeah, I can go back to my raw data. Let's go here and same process. Yeah, identify visually my arrivals. Once, yeah, I can work with this one. Same process. And there we go. If I go back here, we should have two trigger events, or with a hyphen on it. They're not properly triggered, but they are extracted events, as we call them. Yeah, you can see that here. So that's one way to work with InSite-Lite. Let's cut this. If the data has been previously processed, I'm going to show you. In this case, well, I have this previously processed data, in this case in ESF format. I can select it. Ask to import it. It's a bit bigger in this case, a bit longer. And here we are. This is some data that has been previously processed. Yeah, and as you can see, yeah, we can navigate, as you can see, using these cursors in between waveforms. We can use the global bottom bar to navigate in between the different visualizers. Okay, so this covers our extracting events and detecting our events. So next step in our workflow will be pre-processing. I'm just gonna quickly talk about it. And what's involved in this pre-processing? Sorry for the typo in the slide. Well, something that InSite does, and we don't control it, it's done by default in the background, is removing the DC component. And that's done by taking an average of our trace and removing that average from our trace. Basically, just to center the trace around 0. And then we have the option, more limited in InSite-Lite than it is in the full version, of filtering our trace. The only option for in InSite-Lite will be using a bandpass filter with a low cutoff frequency and a high cutoff frequency. Yeah, and we can see here the effect of using this bandpass. In the full version, you have other options for filtering. You can combine two different filters, or you can use your own filter if you have the function that you know you want to apply. Okay, so this is just a pre-processing, and the next step will be classifying our triggers. As I said before, our triggers could correspond to man-made shots, calibration shots, noise, or events. And as with any Windows program, yeah, you work with events as if they were files, and we can label them and attach a label to them, whether we visually identify them as an event, as a shot, as noise, or give them our own labels if we have other classification for them. And I'm going to show you it's, in our software how we do that. This is example I used before, just by going into the waveform. Here we can select what do we think our event is. Why is this useful? Because, well, if we go back here to our catalog, we can use this classification to enable or disable events according to the classification that we have for them. So we could select to, if I use this option here, sorry, if I go to the, yeah, as you see, I can enable all of the events, disable them, or just disable events based on this classification. The idea is that we don't have to process noise, we don't waste time processing noise, or we only process the events that we are interested in processing. Which takes us to the next step, which is the main one, which is processing. And processing events involve identifying our arrivals. This is a quick sketch. You surely are all familiar with this, which is what's inside our seismic wave. Where normally are the two basic components that we can identify typically are a P wave, a compression wave that travels in the direction of propagation, and also it's faster than a second arrival, which is the S wave, which basically vibrates orthogonally to the direction of propagation. And we can use these two properties to identify them. One main one is the difference in speed in between both, propagation speed in between both, and the orientation of the vibration. So we can analyze the traces, and we can have a look at the polarization and the vibration of our trace, and use that to basically discern whether it's could it be a P wave arrival, or could it be would it be an S wave, or will it be any other phase. So yeah, we can use both criteria like linearity, polarization, and we can also, of course, use arrival time to detect or to pick our arrival. And the next step, but before that, I'm going to show you the tools that we have in InSite for that. Let's have a look at that in InSite. Yeah. So we have here our traces. Have a look at waveforms. This is quite a nice data set. We can see them in two different ways. Probably this is easier. Yeah, quite a nice one. We can see a clear fast arrival and a later arrival. So in this case, it will be the P and the S. But if we are not sure, we can click on one of them. just pick, select our P-wave arrival, and in this case, I'm gonna select hologram. Have a look at them rotated, and yeah, here we get what would be our linearity of the arrival I have picked. Can move them until I optimize that linearity. Yeah, so the maximum will give us what would be probably what should be our P-wave arrival. And here we can also give us automatically the source vector for this arrival. On InSite-Lite, we only have the option to manually pick our arrival. Of course, automatic picking is available in the full version and with different algorithms to detect this arrival. So, yeah, very simple. We can go back to the general view. We can see all our traces. These are shown individually as different tools. If we have a linear array, it's easier probably to use this view, the move out view. And we simply have to add our arrivals manually. A bit painful, but this is one of the disadvantages of a free version, but we can still work with it, as you can see here. So once we have our arrivals detected, the next step is locating our event. That's the main step in any seismic processing. And location is based mostly on the separation of the P wave and the S wave arrivals. As we know, they propagate with different velocity, and as they move away from the source, they will be separating. So we can use this fact to try and invert for our location. In InSite-Lite, we have only these options using a grid search for our location as an inversion algorithm. And we only can work with homogeneous isotropic velocity models, which in many cases is a good approximation. But yeah, in most cases, geology is never homogeneous or isotropic. So yeah, we need to work with more complex models. So introduce anisotropy, introduce layers, or introduce a 3D model. But this is only available in any full version of InSite. But how is the way that InSite computes, finds our location? Well, it's basically optimizing. It's optimizing the position in the space that will minimize the difference in between theoretical and observed travel times. In the full version, it's not only travel times, it's also comparing orientation, source vector. It's the vibration of our P or S wave. But yeah, the grid search works like this. It just searches across our volume, finds the difference in between both, what would be the theoretical and what would be the observed travel times, and whatever it's giving us the optimal location, that will be the solution. And of course, this relies heavily on having a good geometry and having a good number of sensors. Otherwise, our solution has the risk of not being unique or not being well determined. And what do we mean by collapsing grid search? Well, this is a concept. We have residual space. This is just all the difference in between the theoretical and observed travel times, or in this case. And we will grid our space, divide it in a lattice, in this always cubic parallelepiped lattice. Do a first coarse search, and then do a finer, take some steps with finer grids until it defines the optimal location. So this is an iterative process. It goes it tries to fit all of our observations. If one of them results to be an outlier, takes it out and repeats the process in different iterations until all of them are within our desired residual. So let's go to InSite and see how this is defined and how it works. So here we have an example that I've previously picked. This is data from a mining project. Very good PNS arrivals. In this case, our move-out view doesn't make sense because it's a good 3D coverage. Let's have a look in space. This is what we have. These are the seismic stations, and we have a gallery being excavated. We have the outline for it, the plans for it. And we are monitoring the activity induced around this tunnel using all this quite a very good seismic array, three-dimensional seismic array around this gallery. The cube or the box that we can see here, it's our grid search space. So we've tell InSite that our solution will be within that space, and it will search in it. How do we configure that? We go to processing settings, and we go to locator. Well, we can see here the options. We can see we only have one option. The other options are only available in the full version. We select our collapsing research. We select our velocity model. In this case, homogeneous isotropic. That's because we don't have any other option. We select what would be the minimum number of tools that we want to use. So 3 is a bare minimum. I would probably put it up to 4 to have something more robust. And what would be the maximum residual I'm going to allow? This is the maximum difference in between theoretical travel times and observed travel times. So in this case, I would set it to 1 millisecond, which is good enough for the resolution in this setup for this array. And here we can further configure our space, our spacing, our search space, the spacing we are going to try and find our solution. And this is done here. You can see this is the dimensions of the box. This is the course, the resolution of the first search. In this case, it's 1 meter, but at the end we want to reach a resolution of 10 centimeters. And the buffer, that means how many steps are we going to take in between this course and course search and our fine search that we're going to perform at the end. So that's it. Well, one more thing to remember. Yeah, here we can define, in this case, all we can define is the velocity for our P and S waves. It has to be, we only have the option for a homogeneous isotropic velocity model. If we had any other options, we would define it here in this screen. We would define, import our layer model, or define our anisotropy. Okay, so let's go back to our waveforms. So this one's processed, it's picked already, very easy to pick. This is a very nice example, probably once in every 100 projects we find one of these, and we can locate it, and it's done. And this dialog, which we can export as a text file, it's very useful because it's quite informative about the process that InSite follows for this location. It's telling us what sensors are we working with, the number of peaks that we have initially. In this case, we are working with 15 good P-wave peaks. No S-peaks, no use for S-peaks in this case, so we're going to be using the P-wave arrivals. And yeah, it does one iteration, it does one pass, and it finds, in this case, that, well, all the arrivals are good. There's nothing above the residual of 1 millisecond that we said, so it's going to use all of them. If one of them was a clear outlier, which I'm going to do now, let's say I'm going to move my peak here. Let's have a bad peak, and I locate. Well, we should see in this case that after the first pass, the instrument 11 that I moved wasn't good enough. The arrival didn't match the pattern observed in the rest. So it drops that one, it does a second pass, and it finds that all of them are good in this case. So it will not use it, it will use all the rest. And it's located. And we can go to our 3D visualizer, back to our 3D visualizer, and see where our event is located. In this case, it's very typically, it would be either on the roof or the floor of our gallery. In this case, it's on the roof. And we can see it there. If we cannot find it because we have many events, we can make a jump to call attention, but yeah, it is over there. And this is very quickly, very simply, the process. We can repeat it for more of them. With InSite-Lite, we have to go one by one. If we were working with the full version, we should be able to automate this process. Yeah, we can see this is our latest event, and it's displayed there. Okay. So let's move on. So once we have the basic results for our events, which is the location of our events, and automatically it has calculated source parameters for it, such as magnitude, depending on the sensors we were using, if they're calibrated or not. It will use an absolute, it will be able to calculate an absolute magnitude. If not, it will always calculate a relative magnitude based on the amplitude, because we always have amplitudes. So once we have that, our next step is just analyze what we have, analyze our results, and eventually export them for further analysis or further processing on other tools that we have. And we can export either our seismic catalog and analyze our seismic catalog, which will have our events and locations and parameters, or work with exported waveforms. So let's have a look in InSite how this works. And I'm going to show you two examples. This is a basic example in which I have processed all of my events. I don't have waveforms in this case because I'm working with the catalog. So I can here export a text file in which we can decide how the level of information that we want to add into it. Whether we want to have basic, that will be just timing of our events, location of the events, source parameters, analysis of the residual that will help us in estimating what's the uncertainty that we have in our locations. If we have source mechanism as well, anyway, anything that we want. So yeah, we can export our file as we would export any text file, and it will come as a CSV file. So yeah, select that one. And it's done. But we can also use InSite to analyze catalog data, and it's quite useful. We can go to the 3D visualizer because, well, the first level is just seeing where our events are and when do they originate. And we can use our 3D visualizer for that, which has some tools that you can see here for the analysis. If we open our properties, we can see that we can select what symbol we want to use for our events, but more useful, what scale do we want to use? Do we want to use color our events by time, as it was selected here, magnitude, any other property that we have processed, uncertainty, number of P waves that we have used in its location, etc. I was using time for this, and we can combine two by using size and time. Sorry, size and color. So as size, typically we will use a magnitude because it's more intuitive. We can see small events will be smaller, large events will appear as larger spheres. But also we've got here the time tab in which we can create a movie, or we can generate a movie, play our events in time, because that's quite a useful information. You can use this tool. It's already set here. Okay. And launch the player, and yeah, you see that we'll be playing. Because the basic information for us is how many events we have, where do they locate, and also when are they generated, in case we can relate them to some engineering processes that are going on in our setup. This case I'm showing here is just activity that was induced by thermal loading of these two boreholes. One was confined and one was unconfined. So, and we can see that there's much more activity in the one that is unconfined. Basically, we had a free surface here for our fractures to open. Yeah, but yeah, these are the tools that we have in InSite to analyze the temporal, spatial patterns, etc. But I'm going to open different projects. Something that is very useful is, well, if we have our waveforms here, we might want to do some further processing, some relocation, relative location, and some use our own algorithms for picking it. In this case, yeah, we can use this tool, which is the exporting our traces, and we can export it, exporting in these four formats that we have here. ATF, which is a simple text file, very useful if we want to process them in Python or some of our own algorithms, but also in some standard formats such as seg1, seg2, and miniseed. Right, so we've reached now the end of what would be the basic seismic processing. And the end of this webinar. And this is just a slide showing what would be the full version of InSite, which is packed as in these other three packages: InSite-Geo, which is the most general package for seismic and microseismic processing; InSite-Lab, which has tools more specific for the lab environment, for rock testing in the lab; InSite-HF, which is probably our most complete package, which it's got tools for managing well data, especially designed for stimulation of reservoir using wells. And of course, InSite-Lite, which is this version, this free version, which is freely available for any of you to use. I'm just presenting a new package that will be launched in the next few days, which is a subscription package inside EDU, which has limited tools, a few more tools than InSite-Lite. So it allows for the calculation for auto processing. It has some more velocity models, capability for more velocity models, but also includes some tutorials, includes some material that you can use in the classroom for teaching seismology, for the teaching of seismology or acoustic processing. As I said, this will be launched in the next few days, and we will send full information to all of you, and it will be available in our website. And that's it. So more information, yeah, go to our website, or you can also visit our YouTube channel or LinkedIn. Our YouTube channel has more videos with the different. Just going in detail into some of the tools of InSite mostly. Also, this webinar will be uploaded there, and it will be available for all of you once we record it. Once it's available in the next few hours. Or drop us an email for any more information about either InSite, general seismicity, or any of our other services. So I think it's time to open the floor for any questions that you may have. So Nicola, can you?
Thank you for your presentation, Juan. That was really helpful today. The first question we've got is from Vic Elp, and it's, what does a 4-channel attestation mean?
All right. Well, yes, it's more than physical. It's more like a computational issue in InSite. I'm going to open InSite and show you. Yeah, when we are setting up our stations, our channels, we've got the capability to add up to 4 channels per station, per sensor. And it's not very usual to have more than 3 access in one seismic station, but there are cases in which we have a calibration channel, a calibration sensor added to it. Or in some cases, it's more research type, but some companies supply this, combining an additional sensor that, for example, combines geophones and accelerometers, so that we can cover a broader band. So it's basically just the capability of InSite to take up to 4 traces per instrument, although it's not an usual setup.
Okay. We've got a 12-second lag, so thank you for that, Juan.
Okay, sorry.
So I'll just wait if there's a few more questions come in. I will close the poll now as well. If anybody else has not had a go and they want to do it, I'll just do that in a few seconds.
Okay.
I think that's it for questions. Thank you.
Okay, well, thank you very much. Thank you very much. Oh, sorry, I think we have...
I'm sorry, yes, I just spotted
yes.
another one. Do we have to enter the coordinate of the surface or the actual position of the geophone?
Oh, do we have to enter? Oh, it's it's the actual position of our geophone. Yeah, so we need to enter the northing, easting, and depth, the 3-dimensional position of our instrument as a coordinate. Yeah.
Okay, thank you. Just give it another 12 seconds.
Yeah.
We've got a question in from Valant. What kind of velocity model do we use in grid search? Also, do you use any ray tracing algorithm? Sorry, ray tracing algorithm.
Yes. Yes, thank you, Bulent. In InSite-Lite, it's, as I said, it's limited in the number of options that we have. So basically, grid search will take any velocity model, will take up to 3-dimensional voxel models in it. It will take layer models. It will take isotropic layer models and isotropic layer models. And yeah, it does ray trace. It's got different options. You would see here the name Tian ray tracing. That is 2-point ray tracing. It's a bit of a faster ray tracing. It's got a VTI, a full ray tracing that goes through basically all the interfaces that it finds, which is designed for 3D models. Basically, there's ray propagation in between the faces of each of the boxes that define our velocity model. We also have, not in grid search, we have the option for source scan, which it's very similar in the way it propagates. It's a migration algorithm and basically focuses energy, tries to maximize energy measure around it. But the logic is very similar to the Tian ray tracing. None of these options are unfortunately available on InSite-Lite. They are available on the full version, but because there was a lot of work involved in implementing them.
Okay, I've got another question from Vikal. Can we upload AutoCAD file for mine layout?
Good question. Yeah, unfortunately, at the moment, in the current version, we only take very old version, DXF files. You can, in the next version, the coming version, so this is a bit of a commercial, you can import STL files that are, you can create them with AutoCAD, or any 3D printing software will also create these STL files. Regarding DXF, only if they are created with software packages like Rhino, then they are accepted. From AutoCAD, it has to be from older versions of AutoCAD, basically 2014 or before or earlier.
I have a question from Pepe. Can we integrate with geological layers or structural geology?
Well, it's good question. It's a visual integration that you can do. Let me show you, for instance, if we have something like this. If you have all AutoCAD or STL files defining your geology, I don't have here an example. I can send you an example where we use it in the case of a mine, where we have the outline for the ore and all other geological bodies in it. You can visually plot your seismicity against them, and it's a nice option that we have here. It's that you can use those files to filter events. That means you can actually enable or disable your events regarding whether they are included or not in one of your geological bodies, and analyze them separately, if that helps. You can also draw directly on InSite, but because I'm using the free version today, I can only draw planes. But you can draw planes, which I can adjust, so I can change the thing. So you see, I can play with them. If I know geological structure, I can draw it. I can draw if there's a fault going above my tunnel, I can draw it. And I can analyze especially how my seismicity goes around it.
Okay, my next question is, can you show again the event selection from the whole waveform, please? We do need to be careful, Han. We've only got about 5 minutes left of questions.
Okay, I'm going to be very quick with this.
Okay.
So back to what we call the leech. So let's have a look at, we need to go to our waveform. It doesn't matter if we are in this view or this one. In this case, because we're dealing with downhole data, it's better to plot them as a move out. I just dragging my mouse with a left click on it, select the section that I think corresponds to an event. Sorry. I keep zooming in, and then I just select this option, create time cropped event, and I can then save it to a folder that I have previously created, and it will save it as a new event. It will just save whatever I'm seeing in this window. Okay.
I think we can just squeeze another couple of questions in. Can we use InSite-Lite to process field seismic data?
Yes. Yes. The difference between the different versions is they have additional tools, more customized to a certain environment, but they are all scale independent, basically. So yes, you can work with either version in either setup. Only that, for instance, InSite-Lite has tools that integrate with our lab equipment, acquisition equipment. It works. It can visualize full streams acquired in the lab. But that's the difference. In terms of processing, yeah, you can process any type of data from big earthquakes down to small acoustic emissions.
Okay, and the question from Anna. I would be interested in seeing the example with the integration of lithology and structures. Okay, well, sorry, Anna, I don't have it here with me. Yeah, I can see the question. If you drop me an email, I will definitely send you that example. Yeah. Okay, I think we're going to have to call time on the questions now. Yeah. We will get back to the other people that ask the questions, and we can give you an answer on that. Is that okay, Juan? Yes, of course. Yeah. Okay. Yeah, sorry, it was rushed, but yeah, we have a limit for an hour for this. I will go back to any questions. Just drop us an email at any point. Yeah, I will try and answer all of them. Okay. Thank you for your time today in the presentation, Juan. Well, yeah, and thank you, everyone. Thank you, everyone, for your interest. We are here to answer any other questions. We will post a new webinar in the next week or so. I have to say one of them will be in Spanish for any Spanish-speaking audience, which is my native language. But yeah, there will be more occasions where we can discuss. Thank you very much again. Okay. Thank you, Juan. Bye. Cheers. Bye.